welcome to another video tutorial with Märklin of Sweden. Joe, I got a bunch of devices sent to me here. It's Märklin 75491 from a guy in Sweden. He says he has a problem with this. It's turnout motors and they don't turn. So that is indeed a problem. I've been doing some investigation. There is some information on both YouTube and also on forums, various forums on this, so it's a known problem. But I guess this will be out there for some time, and that's why you are watching this video, I guess. Because there are two switches inside of these. The purpose with the switches is that once the turnout has turned, the switch turns the power to the motor or the solenoid off, so you don't get the overheat situation. The problem is that the contact surfaces are to some extent made of silver. It's a silver alloy, and silver over time builds oxide corrosion. That corrosion, silver oxide corrosion, is a black powder and it is non-conductive. So what happens is that the contact closes, you will get a corrosion around the contact surfaces, and the contact open again, you will get some arcing typically, especially if it's an analog system where there's more power involved than in a digital system. So the arcing will burn off the oxide. However, in a digital system, the signals are different, so there won't be much arcing happening, and that means that the corrosion, the oxide, will stay. And since there are mechanical contacts, they will stand like this one time and another time that, and over time they will stand in oxide and your turnouts will not work. So now we will bypass the switches, and this is how it's made.
So here's the turnout motors. Let's put those aside for a moment, and let's start by snapping off the plastic cover from this. It's just to snap like that. So this is the coil which generates the magnetic field. The power comes in through this cable here, and once it's powered, the mechanism moves, closes this switch and opens the other switch. Same thing happens when you power the other coil. The mechanism moves back, and this switch closes and this one opens. Easy peasy. To bypass these switches, we will solder a cable here and a cable here. I use a bit of cable from another switch which I just had laying around. Start by tin plating it a bit with a soldering iron, and then solder the first one in place like this, cutting the excessive parts, and doing the same thing with the other side. Oh boy, I'm really shaky here. Alright, I think I got it right anyway. And off it goes. And this is what it looks like when done. So just check that it actually operates. And then it's time to reassemble the cover back again.
Well, that's what I call a simple fix. And then your switches should be good to run for the life of your layout. In digital, you know, I see in some forums here on the internet that there is some talking that after removing or shorting these switches, they're only for digital use. And I got curious, I just had to check, so I made a continuous power of a modified K-track solenoid switch motor, and I put my finger on the coil, powered it, and I could have it powered for about 4 seconds before I burnt my finger. That is to be compared with this. This is a pure analog device used for 100 years. This one can be powered 12 seconds, so not so big difference really. They should of course not be powered continuously like that at all. It was just to test. see the difference. It should be maneuvered with a momentary switch box like the 7072, for instance. And anyway, if you are running analog AC, and you will never see any problems, most likely, with these switches inside the motor, because it is related to digital systems. Well, that was about it for today. So, thank you very much for watching this tutorial. If you like it, please help me by giving it a thumbs up. Don't forget to subscribe on the channel, and you will get a notification once next video goes live. Until that happens, see you!